Hello friends, have a good day. Welcome to my YouTube channel. Learn with me, Dr. Ram. Happy learning. Today we will discuss a small topic which was related to orthodontics, prosthodontics or dental materials, which was basically mainly dealing with the components of wire and its wire and internal structure, the mechanism. The topic we are going to discuss is stress strain curve. Okay. The stress strain curve is basically deals with. Before going to the topic, we'll discuss some important abbreviations or some important words. Yeah, that is first one is stress. Stress is basically what we all go through. It's okay. Yeah, stress is mainly in the aspect of dentistry or in the aspect of the wire. The stress is mainly the force. Okay, the amount of force that we are going to apply onto the material or the wire is stress. Then the second word we are going to learn is strain. Okay, due to the amount of stress I am giving onto the wire, the amount of deformation, it is the change that was occurring in the wire, that is known as strain. Stress is force and the strain is deformation that was occurring on the material due to the stress or force that I am applying on. Okay. Then the third word we are going to discuss about is elastic modulus. Elastic modulus or Young's modulus, that was basically dealing with the quality of the material or the relative rigidity of the material or the thickness of the material. Okay. The relative rigidity of the material means how much the rigid the material is basically, or how much thicker the material is. Okay. If why we are going to read about elastic modulus was, if the thicker the material, more the stress will be needed to deform the material. So if the elastic modulus is more or Young's modulus is more or relative rigidity of the material is more, then the strain, that is deformation occurring from a constant amount of force, is going to be the less. So elastic modulus is going to be the high. If elastic modulus is high, then the strain or the deformation is going to be the low or less. Okay. Next, the fourth point we are going to learn about is elastic strain. What is elastic strain? Elastic strain means, if this is the material that I am going to apply the force and it was going to the deform like this. Okay. If it was getting into the deform like this until a point where the material I am applying the stress can be reversed. See, if I am applying the force like this and the material can be reversed. So the point where the material can be reversed until a point. Okay, don't get confused. I will show a graph in the next thing. And yeah, elastic strain is the amount of strain I am giving, but material can be reversed. In that state of the material, elastic strain. Plastic strain or the permanent deformation. That means if I am giving the strain more than the elastic strain, exceeding the elastic strain, I am still applying the stress or strain. Okay. Then the material is going to the plastically deform. That means if I am further rubber, it won't be there. So if I am applying the more and more of pressure on the wire during wire bending or anything, then the wire can go until a point where the wire can revert back. That is where elastic strain. And after a certain point of time, if I am bending it more and more, the plastic strain will occur. That means the wire, if I bend like this, the wire is going to be in that state only. It was not going to revert back, or it was not going to spring back into its original position. So that kind of position the wire is going to be there is known as plastic strain or the permanent deformation. Okay. Then the next word is proportional limit. What is proportional limit? The proportional limit means, we have discussed about what is stress and what is strain. So the amount of force, that is stress, is equal to the amount of strain. That is what proportional. That is, stress is directly proportional to the strain. Simple words, stress is directly proportional to strain. The amount of force I am applying is equal to the amount of deformation that was occurring. So that is proportional limit. And there is something called as Hooke's law. So according to Hooke's law, what that means, the proportional limit, that is until the proportional limit, it was fine. So when until stress is equal to strain or stress is directly proportional to strain, it is proportional limit. If the material exceeds the proportional limit, that means when the material got or enter into the plastic strain or plastic deformation or permanent deformation, then the stress is not directly proportional to the strain. Okay, then the stress is inversely proportional to the strain. We know what is inversely proportional, that is two are oppositely will be there. If one is increasing, oppositely then other one will be decreasing. If one was decreasing, another one obviously going to increase. So according to Hooke's law, that was a topic or concept. And what is elastic limit? What is elastic limit? Now until now I have spoken only about the strain and the deformation. I am applying the deformation and everything. Then what is elastic limit is the stress, that is amount of force, the maximum amount of force that I can apply onto the material until the material gets into the plastic deformation or the permanent deformation. So that is what the limit, that is where the amount of force that I am applying on it material to get into the plastic deformation, that end point or end reach limit is known as elastic limit. Okay, next the 8th point was yield strength or proof stress. I will come to it later. Now we will go into that graph. This is what the stress strain curve looks like. Okay, don't get scared. Now this is what the stress and this is strain. X-axis is going to be the strain and y-axis is going to be the stress. Now the material, or this is the material we are going to represent. This is a wire. So I am applying the pressure onto the wire as the stress is increasing and strain is also getting into the deformed or deformation. When I am more of stress, it was going to the strain. Okay. So the point where this is what the proportional limit I said. So where the stress is directly proportional to the strain. Okay. And we will see about what is resilience in this word. Resilience is the amount of energy. The amount of energy that is absorbed by the material until the plastic until it become into the proportional limit or during the elastic strain. Okay, that is what the resilience of the material. And next word we will see about is toughness. So the amount of material, the energy, so not material, the amount of energy that is required to break the material or the make the material to change into the plastic strain. So after the plastic strain, and it was going to not going to the irreversible state. So after the plastic strain, so before that, the amount of energy that is required for the material to get into the plastic strain or that needed for the material to break. Okay, and another word that we is going to say UTS, that is the ultimate tensile strength, where the material is going to the break. That means if I apply the pressure, if I bend more the wire more and more and more and more, at a certain point of time, it was going to the break. So that point of breakage of the wire or the material is known as ultimate tensile strength. So now we have skipped one word called yield strength. So yield strength or proof stress. That means that's the main thing that we are going to do in our orthodontics during wire bending or during these things. That is, wire we are bending our wire, so we are going to make that wire into some sort of position. So after the plastic strain, so we are going to place the wire into the plastic strain only, right? So in the point where after crossing the proportional limit, the material is going to slightly deform. That means if you bend lightly, it was going to bend lightly only. So the material wherever I want to place or whichever position or I want to give, that material, that kind of deformation limit is known as yield strength or proof stress, that can be visible. Okay, that is a visible stress or proof stress, whatever. And the next word I am going to speak about is ductility. What is ductility? Means the amount of after the proportional limit, that is after the proportional limit, even though I'm applying the pressure onto the material or I'm applying the strain onto the material is does not going to the break, but it was how much amount of material that is going to the withstand the pressure, withstand the strain, is known as ductility of that was dealing with the ductility of the material. That means if after the proportional limit, if I'm making bending more and more and more, if the ductility of the material is more, then I can bend more or I can do some sort of things. If material has no ductility, no property called ductility, then after a certain of proportional limit, the material is going to break. See, after the proportional limit, there is I can't bend the material into the irreversible state. After the proportional limit, that is where the reversible state ends, the material automatically going to break. So for that material, the ductility is very low, that means no ductility, so material is going to break. High ductility means the material can be used in a very nice way. Okay, okay friends, with this one I am going to end this. Thank you, hope you liked my video. If you like my video, like, subscribe, share and comment which part you like or which part you didn't like. Thank you.